Hello, it's Professor Todd. Let's look at the implementation of a basic motor start-stop circuit using logic gates. So we're just going to replicate a standard motor start-stop station with the ceiling contact and how we could accomplish that with logic gates. Now, this is a simplified circuit, so there's more circuitry using optocouplers and transistors and other resistors and things, which maybe we can cover in another video, of how to bring in real world signals from an operator control station, which would probably be run at 24 volts. And there's no other safety or protection features added in. This is basically how you do with two gates. How do you just kind of make it work, and then it can be much improved on from there. So here we're going to have a OR gate, and that's going to feed into an AND gate. Okay. And that's going to go then and go off to the rest of our circuitry to start our motor. Okay. This input here, I'll run it to there. So this, we will call it stop. And I'll put it, I guess, here. This one is called start. And that's going to go there. And that's going to go to there, okay? So we're going to assume then that the circuitry that's creating these, that is going to give us a logic 1 when the switches are closed. Okay, and that's very simple to accomplish using optocouplers and a couple of resistors and some switches. So that's not a problem, but we'll just assume that's the case. So we know then for a standard stop button, it is normally closed. So that input circuitry will be designed to give us a logic 1 in its rest state. And the stop button is normally open, so that's going to be giving us a logic 0, okay? Assuming the system was reset, again, this is only a partial diagram, and then the output here was low, which means that is low, which means that is low. So the system then is reset. The AND gate output is low because one of its inputs on the stop is high, but the other one coming from the OR gate is low, so the output must be low. So then we're going to go and depress the start button momentarily, and that means that this input here is immediately going to transition to a logic 1, which it will make that logic 1. Now we have a 1 and a 1, logic 1, which feeds back to course here, right? And then so the whole system now is steel then, and now we have a logic 1 coming here, and that'll feed the rest of the circuitry. If you release the push button now, no problem, because even though this will then transit back to 0, it doesn't matter because we still have a logic 1 there. So this bit here, this bit right on here, that's like your seal-in contact in parallel with the normally open start button in normal ladder logic. That's what that does. Okay, so now we want to go and stop the motor from running. Okay, so we're going to momentarily then depress the normally closed stop button. Okay, and that will then transit this from a logic 1 to a 0, which, because this is an AND gate, that will go to 0, which means that goes to 0, which sends that to 0, and then the whole thing drops out. Okay, now there's some extra circuitry you'd really would want to add in here, but this is just the basic functionality, and then you can just build upon from that. Okay, all right, have a good night or day whenever you're watching this, and we'll catch you later. All right, cheers, God bless, bye.